Hi, I'm Dacia Cipher, and this video will demonstrate how to compute a Wilcoxon signed rank test using SPSS. Example comes from the third edition of the Statistics for Nursing Research Workbook. Recall that a paired samples t-test does require that the dependent variable should be normally distributed. If you find that that variable is not normally distributed, then the appropriate non-parametric alternative is the Wilcoxon signed rank test. Now, remember that a paired samples, that phrase refers to generally a pre-test, post-test design of a single sample where you have the same group of participants assessed repeatedly. Very different from an independent sample scenario where you are comparing two totally different groups of people. Be sure to watch my video on how to test normality of your distribution with three basic steps. So you'll want to go through all of those to make the conclusion that your dependent variable is either approximately normally distributed or non-normally distributed. As you can see here, this is what our data set looks like in SPSS. We have 12 participants from a study of people suffering from GERD, gastroesophageal reflux disease. The researchers withdrew the patient's proton pump inhibitors, and the patients were not allowed to take PPIs for a period of 2 weeks. So they were followed continuously for all sorts of changes in esophageal related indices. And one of those variables was a self-reported instrument called the GERD HRQL, which is health related quality of life, where you see here we have 2 assessments, baseline, and then a 2-week follow-up. Now for this instrument, higher numbers are indicative of more esophagitis symptoms. Lower numbers are more desirable. They're indicative of fewer esophagitis symptoms. Notice that there is no group coding, dummy code variable in this data set because we are assessing, this is a paired samples data set where the same group of people were assessed repeatedly, right? So we have baseline, and then they were assessed again at follow-up. So no group variable necessary for those kinds of designs, and therefore this kind of data set. So I will show the third step of the test of normality, the Shapiro-Wilk test of normality, so that you can see. I'm going to go to Descriptives, Explore, Plots, click on Normality Plots with Tests, and OK, so that you can see the results of those tests. So we have that the baseline scores were indicated a significant deviation from normality, p equals 0.005. And also for 2-week follow-up, the score significantly deviated from normality, p equals 0.044. So that tells us we need to compute a non-parametric statistic instead of the planned paired samples t-test. So we're going to go to Analyze, Non-parametric tests, legacy dialogues, and 2 related samples. We'll move over our baseline and our 2-week follow-up scores. It doesn't matter which one goes in which cell. The results will be the same, and click OK. And the other thing we are going to need to do is obtain medians for the baseline and the follow-up score. So analyze, descriptive statistics, frequencies, and we want to move over our 2 variables, click on statistics and median. Now, why am I not asking for the mean as well? Remember, we've already demonstrated that both of our distributions significantly deviated from from normality. And therefore, a mean is not very useful to us because it's that one measure of central tendency that tends to be extremely affected by outliers and skewed distributions. But the median, of course, is not, because it's the middle number. So we click continue and OK. Now we have everything we need to understand our results here. So the first thing we have is the Wilcoxon sign rank test. The first table is a kind of descriptive statistics test, but instead of reporting means of the raw data, remember, this is a non-parametric test. So the formula for the Wilcoxon sign rank test actually ranks the data and converts the raw data into ranks. So it orders the data. And then the formula is applied to those ranked data. So it's reporting mean ranks here. And the easiest way to understand this table is to pay attention to the superscript letters here. So 1 superscript A will go down to A. This table is telling us there is one instance where a patient's 2-week follow-up score was less than or lower than their baseline score. Then 11B, there are 11 instances where the patient's follow-up score is higher or greater than their baseline score. Now let's go to the actual Wilcoxon sign rank test statistic. The Z is negative 2.67. The p-value is 0.008. Of course, that indicates a significant difference because it's less than 0.05. So we know that there was a significant difference between baseline and follow-up scores. And here's where our medians will come in handy. The median baseline HRQL score was 2.0. And then at 2-week follow-up, it increased to 7.5. So now we have all of the information we need to interpret our results and write it up. So using APA format, we can say a Wilcoxon sign rank test computed on HRQL scores revealed that the patients with GERD undergoing the withdrawal of PPIs had significantly higher esophagitis symptoms from baseline to follow-up. Then I report the Z, the P, and the medians. Now you want to remember to report the medians in the correct order. Baseline first, and then a post-treatment or a follow-up last, right? Hope this helps. Thank you for watching. Be sure to subscribe to my YouTube channel, Statistics for Nursing Research.